Hi, and welcome back to the Route Exam CCNP training from TrainSignal. I'm Joe, and I'm glad to be back with you. This particular lesson, we actually want to look over our lab because I'm a firm believer, and so is TrainSignal, that the most important way to be able to facilitate learning is actually using hands-on demonstrations, and in addition, hands-on practice. One of the greatest ways to be able to reinforce things is to be able to do it in a hands-on environment. Some people are visual learners where they read things or see things and can remember. Others are more auditory where they listen. But everybody learns through hands-on experience, so we want to be able to facilitate that as part of this lesson. So what we'll be doing in this lesson is we're going to look a little bit at our lab topology. How is it laid out? What equipment is involved? We want to talk a little bit about the initial setup that's involved, because generally with equipment it starts out pretty much with a clean slate. Then we want to outline the tasks that we're going to be performing over the course. These are going to be done in sections along with each lesson so you can understand how the pieces fit together. It's a lot like a big puzzle, and understanding how the pieces fit together, you can look at the picture of it all when you're done. We'll also examine what the desired end state configuration is. When all is said and done, what should it look like? What should be in the IP routing table? What protocols are going to be in use, and so forth. And then finally, how does this actually map to the test? When the rubber meets the road, how does this help prepare you for that exam, and essentially the exam blueprint requirements? We're going to take a look at that as well. So first, let's take a little bit of a look at the topology. This is the physical layout. You can see that there are 10 routers throughout the entire lab. There is an ASA firewall with an internet connection. Because of the importance placed on frame relay connectivity, we have that factored into this as well. So there's quite a few devices that are involved in this. So this is going to give us an opportunity to trial the different protocols and features and topics that will be a part of what we'll be learning. And this is the mapping of how we're actually going to be working on from a protocol standpoint. The three protocols that are a part of the route exam are EIGRP, OSPF, and BGP. And there's a lot of work to be done as far as route redistribution and path control that we'll be looking at. So a lot is in here that we'll be examining. So on the left, you'll see we have our EIGRP domain. We have a number of routers there. You'll notice that the default route to the internet will be propagated from that point. You'll notice R1 and R3 actually have two separate connections. This will enable us to be able to simulate load balancing, both equal cost and unequal cost. In this case, it'd be unequal cost, but I can give you an idea of how that will work. You can see that R5 will be using the EIGRP stub network feature, which will give us an opportunity to explore that more. And we'll be able to build a number of different factors into that as well. OSPF, you can see there are a number of different, we have our area 0. We have several other discrete areas that will require, for instance, use of virtual links that we'll talk about later. We have a stub area. Area 8 will actually show how stub areas and totally stubby areas work. And then finally, we'll actually have our BGP configuration. In this case, we'll be looking at an eBGP or external BGP configurations, because essentially we have two different autonomous systems, one on the left and one on the right, that we'll be looking at, and all the different path control and filtering and so forth. So how would we access the lab? Well, we have a number of different options. One is, because we have an ASA 5500 series firewall, we actually have the SSL-based VPN that we could use. There are easy access through a browser. It doesn't require anything extra. Because Telnet is inherently insecure, there's actually an SSL connection that makes it able to be accessed very securely. So that's one route. Then we also have an internal set of tools that we can use, and this is actually the preferable means that we'll be accessing. CAT tools from SolarWinds actually allows you to be able to set up a one-click access to everything, both Telnet and SSH respectively. It's going to be accessible from my instructor workstation, and I have a terminal server, a pair of 2509s with what's sometimes called octopus or octal cables in order to be able to console access to the rest of the devices. Has backup and restore functions, and there are NAT mappings specifically placed in here to be able to allow specific device rules, and I can be at any location and able to access this particular lab. So the CAT Tools console will actually make accessing this much, much simpler. just want to take a moment to actually demonstrate how we're going to be able to access our lab environment. You can see here is the CAT Tools console, as I mentioned. It's all very straightforward, and one of the nice ways to be able to work this is notice the right click and go Telnet SSH to device, and it immediately goes to the device. So you can do show IP route. I've already got some things configured here initially. Notice we have our routing table. We could actually do show IP route connected. All our connected routes, show IP route EIGRP, since this is in our EIGRP domain. Quite a few things listed here. Show IP EIGRP neighbors. Notice here it's showing all of our router 4 because not everything's been configured. But notice here we've got our default route. We could actually test ping 216.145.1.2. Oh, and we actually have ICMP shut off on our firewall. So it's not letting the return traffic go. You can actually see, though, that it is listed here. Show IP protocols. Showing EIGRP, the networks that are being routed. And of course, show frame relay, PVC, because we've got a number of those. And we've got more PVCs configured than we're actually going to be using in our lab. Notice here the first one going to router 2 is active. Unused, by the way, whenever you see local, it means that it's an active, it's being used. If you ever see inactive, it means something's been misconfigured. But unused here just means it's not currently a part of anything. But notice here, got 102, 103, which is part of, notice the interfaces are identified, and 104, because we have that in our diagram. So a lot of different things that are here and available. Look a little bit at our configuration. Notice our configured interfaces. We've got our VLANs. We've got our point-to-point and multi-point interfaces, as we talked about. We've got our EIGRP. So this is just an example of how we'll be able to access the various parts of our lab. We have this very simple interface, which has everything mapped out through terminal server directly to console connections. So this will be the way that we'll be able to actually configure and then test all of what we're going to be doing in our lab environment. So what hardware will we be using in the lab? Well, a variety. We have 10 routers. We have a number of different types. For instance, what's pictured here is the Cisco 2811, the Integrated Services Router series. We have 2 of those, a variety of other routers. Some have single connections, some have dual connections. There are trunk port connections from the Ethernet side and the capability of running multiple routing protocols, including all the ones that are a part of the exam. Then we have our switching infrastructure, Cisco 3550, slightly older, and our 3560G with an enhanced multi-layer image. It has power over Ethernet, has VLAN and wireless LAN mappings if we were going to be doing wireless. There's DHCP, there's layer 3 routing, there's all sorts of things available in these switches that will enable us to be able to use everything in a maximum manner. And then we also have our ASA 5505 security appliance. It gives us our firewall, it gives us our VPN, our SSL. We have all kinds of other things that are available. And while not a part of this lab, we do have an autonomous access point that's available that's connected to one of the PoE ports on that as well. What software will we be using? Well, we have our iOS for routers. We have 15.x running in the, for instance, on the 2811s. We have 12.3 plus working on some of the other ones. On our switches, we have the 12.2 35 SE5 train. We're running 8.2.1 of our ASA, ASDM version 6.4, which really isn't going to impinge on our operations, but it's something I'm using in the background. And then finally, the instructor workstation is actually using Windows 7 environment. Let's take a look at the number of tasks that we're going to be performing as part of this particular set of labs mapped to our lessons. First, we have our sort of our overview we've talked a little bit about already. We have our basic lab preparation and basic setup. This will sort of be done in the background, but we have obviously a variety of interfaces. If you remember the diagram, we have frame relay interfaces, we have LAN interfaces, we have VLAN interfaces, we have loopback interfaces. These are all pretty important to being able to set up a very robust routing domain. So the IP addressing is mapped out, and you'll be able to see that as we go through. The general pattern that we're following is 192.168.router number dot, and then router number for one LAN segment, one VLAN segment. Then the other, it's a double of whatever the router number is. For instance, router number 1 would be 192.168.1.1. The other network would be 192.168.11.1 and so forth. WAN links usually are using 172.16 and then some combination of the router numbers so you can follow along. The idea is to make this as self-documenting as possible. So if we're looking at 172.16.134.1, 1, 3, and 4 are the frame relay network between routers 1, 3, and 4, and the .1 designates that it's on the router 1 side. It's just a way of being able to simplify things. Then we have our frame relay WAN configuration. We will actually have a point-to-point interface and a multi-point interface in the EIGRP network because of the split horizon issue. You want to be able to demonstrate how that can make things rather interesting. We'll have our initial EIGRP configuration, the basic process, the routing interfaces, and the basics of what you consider an EIGRP. Then we'll get into advanced topics, authentication, EIGRP stub, network summarization, network filtering. And then we'll look into our OSPF configuration, the basic processes, the advanced processes, filtering, and so forth. And then we will actually tie the two networks together using BGP, which will actually be a pretty interesting read when all is said and done. We'll finally go back through and look at how to do redistribution. How is BGP going to redistribute into OSPF and vice versa, and the same thing with OSPF, so that both EIGRP and OSPF networks across BGP, all three protocols have a full knowledge of everything in the network, and essentially from any one device in the network being able to reach all of the endpoints. We'll look at IP version 6. We're actually going to be able to configure it on several devices in our lab to be able to demonstrate ways to do it. And then finally, the branch office routing configuration, because telecommuting and remote workers are constantly being introduced more and more into work environments. So I want this to be able to reflect real life. So this is kind of the general outline of our tasks. When all is said and done, our desired end state, we want to have a fully functional EIGRP routing domain. Everything working, all features that are configured, operational, full reachability. We also want a fully functional OSPF routing domain, regardless of the areas, the IP addressing, and so forth. We want then a fully functional BGP routing domain. And we want all protocols to be appropriately sharing and filtering routes appropriately. We also want to have our fully functional IP version 6 routing coexisting with IP version 4, because that's another important topic on the exam. And then finally, first and foremost, we want reachability both to the internet from all devices in the lab and connectivity between all devices in the lab. So every device being able to ping every other device. And this is, once these criteria have been met, the lab setup will be considered successful. So how do the tasks that we built into the lab actually map into the exam blueprint requirements? Well, to begin with, first requirement is implement an EIGRP-based solution given a network design and a set of requirements. We talked a little bit about network planning, or we will be. So we'll talk about an implementation plan, a verification plan, configuring the routing, verifying that it's operational, and documenting it. This is the same process for each protocol. So we'll outline what that looks like, and then we'll continue to emphasize it throughout the different aspects of the course. For OSPF, notice multi-area OSPF, which you can notice we actually have mapped out in our lab scenario. Again, going through the same tasks of design, implementation, verification, and documentation. Going with BGP, remember there are two flavors of BGP. There's eBGP, which is between autonomous systems, and iBGP, which is BGP within an autonomous system, and there's reasons for doing that we'll touch on later, but eBGP is actually the stated requirement on the exam. So again, same type of thing: design, implement, verify, document. IP version 6, which can be a little bit daunting because it's sort of unfamiliar looking. But once you get used to the mechanics, it's actually quite simple. So again, implementing IP version 6, design, implement, verify, document, and making sure that it's operating correctly both from the IP version 6 domain and the IP version 4 domain that it has to coexist with. Redistribution, this has to do with sharing of routes, making sure that routes aren't then being advertised back in inappropriately, so having correct filters put in, planning, configuring, verifying, documenting. Redistribution can really be a pain, so we're going to take some real steps to make sure it's clear. Layer 3 path control, which goes beyond just simply redistributing routes, but policy-based routing, being able to go through and deal with the basic teleworker, remote worker, branch office type of environment, and then looking at all those types of things and how it impacts both the exam and your development as a network professional. So just key terms from this particular lesson: EIGRP, the Enhanced Interior Gateway Routing Protocol; Cisco proprietary; OSPF, industry standard, link state; BGP, used between autonomous systems using the path vector protocol; IP version 6, and path control, an umbrella term used to describe a variety of methods for controlling routing throughout a network. So what have we covered? The topology overview, both the physical topology and the routing or logical topology, the initial setup of what's involved, IP addresses, interface, and so forth, an outline of the specific tasks we'll be doing over the course of these lessons, what it should look like when it's done, the desired end state configuration, and finally, how the lab tasks map precisely to the exam blueprint. Thank you for your attention, and we'll dive right back into it the next time we meet.